All right, everyone, we're going to transition from the TACMed stuff over to our Amitrol demos now. We've got several folks in here, several trainers. We've got our skill boss, which we'll be going through a little bit, motor control, pneumatics, and then some of our smart processing stuff and mechatronics. So this is going to be more hands-on and interactive than it will be than it is a presentation. So I don't have a whole lot to say as far as these trainers are concerned. Once you get down here, start moving your hands on them. We'll ask questions as we go, and we can kind of go that make it really informal, interactive, so to speak. So you're more than welcome to. If you guys were with the medical group, we're kind of done with the medical stuff now, but there's more still 3D printing and definitely information around. So if you still wanted to kind of peruse, that's absolutely welcome as well. But for everything else, we'll start doing the training on the basically industrial maintenance, technical training, things like that. So appreciate you guys coming. And I guess Mark just left, and he's going to be the one doing this, right?
He's for technical questions.
Okay.
I guess you want to talk about like maybe soccer or how they test on this, what you can do on this.
Yeah, I mean we've covered soccer pretty thoroughly the last couple of days, as you guys know. So the skill boss does cover, I think it's 5 or 6 different functions. There's a lockout, tag out. There's a motor control. There's a bit of a pneumatics. A lot of folks use this as a pre-assessment for hiring. So if someone might come in, you can run them on this, kind of see what their base knowledge might be before as you're assessing their capability of working for you. From a student standpoint, it kind of does a very good baseline. So when someone were to graduate or move on from a community college or tech school, they'll have a decent baseline of what they're going to get into in a factory environment. Because pretty much every factory in America has motor control or electric motors, right? So motor control is a good idea. Lockout, tag out for safety, things like that. So, Mark, if you're here, I'll let you come up. Do you want to run people through the demo on this, or will you?
Yeah.
Perfect. And then how do we want to handle?
Yeah, get started.
All right, good deal. So I'll turn it over to Mark on this one, and then we can get the motor control. No, I don't even know. We just moved it in here. We've also got pneumatics, so feel free to walk around, and we'll just kind of go from there.
So you can actually.
There you go.
So much.
How long is it?
15, maybe. I think that's about the end of the time period because we budgeted an hour and a half for the testing on it. If I actually want to if the hose wants to go in. Nope, I just had to figure out how plugging a hose in works. That one's leaky. So you've got a belt drive on it. Part of what the students do is they swap out a belt drive for a chain drive. So this is made for the CPT Plus test, and then also for like our SOCA C101 test as well. And when they do it, they'll go through how do you lubricate like the oil, or how do you put oil in the airlines, adjusting all the knobs on there, actuators, make it move without making it do that. It'll do, so we have it all set up for testing. As part of it too, it's, show us how a lockout tagout works. Actually show that you can do it right. And that's part of watching. When you do the testing, you actually, okay, cool, we want you to do this. And we just say, okay, do this. And see if they actually follow along the right way. Are they using lockout tagouts? Are they actually following safety procedures with it? Sorry, I just got to undo it all. Oh, is there 3 different PLC options on this thing now?
That's what I'm saying. I did want to point out so I mentioned the Siemens one.
Yeah, we don't want to.
So you can do Allen Bradley ones also.
One of our trainers that predates all 3 of us was purchased with the Siemens.
I mean, if you want to. It's plugged in.
Yeah, no, Siemens and is it working okay?
Should be.
Okay.
Yeah. I think so. This one had a problem. I kind of eliminated an issue. I have this weird jumper. I know they use this for something. I had one of them go bad, so I just plugged it directly in. That's why it usually looks a little cleaner. You don't see that extra cable hanging out there. But all it is, it's just a pass-through. It goes from the HMI to here and then plugging it in. So if you actually did want to go through and program it or use the Smart Factory features on it, where you can plug it into a computer and actually keep track of everything going on, get notifications to your phone, so when you're dealing with the smart factory stuff on it. It's Siemens, so if you guys have used Siemens before, you know it's a little slow sometimes. If you've used Siemens, sometimes the HMIs are a little slow. Like it's just, you know, when you hit the buttons, it doesn't like flash and tell you, hey, I hit a button. Let me get this real quick. Yeah, no, I'm just loading it real quick. So whoever wants to come up and see it, it's hard to describe with you guys sitting there because you can't see it. Somebody didn't mount a camera above it. I'm gonna blame the camera guy over there. He's not listening to me today. Oh, you got the full book too. Yeah, there you go.
So this device, the Skill Boss, you know, delivers about 50 skills that can be assessed. And so compared to the other systems from Amatrol, this device is actually an assessment device. It's designed to assess the learner in 50 skills, and this is an example of the skills. But to review that, Mark mentioned, you know, startup, shutting down the system, adjusting a VFD, doing lockout, tagout, safety, learning about pneumatics. You could assess their skills there using a meter, also adjusting pressures, reading gauges. Okay, those are very basic skills. And then moving into the system, you have, you know, your mechanical side, which they would learn to do alignment, and of course they're going to use basic measurement skills to do that. Lubrication, making sure that their machine is lubricated out in industry. They're going to work with a couple different types of sensors here. There's a pneumatic robot that's there with limit switches, and so the process that the students or this machine delivers. So the parts go in here, and these are blocks. There are aluminum and also acrylic blocks, and so those can be, you drop it in there, and I don't know if that is running, but you can.
I can make it
the
run.
parts are delivered here, and the system will first sort the type of blocks, acrylic or aluminum. Based on that, the PLC program will it'll pass that part, say yes if the part is oriented properly. If it's oriented incorrectly or not in the right orientation, it'll reject it in the first hole that's featured here. If it is oriented properly, this one is oriented properly. It will go through a buffering process, and then it will be sorted by the material type. And so there will be aluminum and then acrylic here as it sorts it out. Here's an acrylic part that is also oriented properly, so it confirmed that, and it dropped it in the second hole. And so this would be, you know, really doing a quality control process. Now we have an error, and one of the parts was introduced in the correct orientation. So now you're probably going to recognize that there is a fault on the screen, and so this would be just like you were working in industry and you had something go wrong with your machine that you're working on. And so now you've stopped production and you're losing quite a bit of money per minute. And so you have to understand what is required to get your machine back up and running, and what you also need to understand what your problem is, right? So what is the problem? Well, we know that the part was entered into the feed in an incorrect orientation, and that stopped the process. So what we're gonna have to do now is take the machine apart and go in manually and remove it, because it is stuck inside there. And so that's what you would do as an operator. If you have something coming through your line and it falls off of your conveyor and, you know, it just gets stuck, you have to go in and shut your machine down. Mark is removing this. Now, when he did that, there's an interlock in the back.
I'm doing it wrong on purpose.
There's an interlock back here in the back. And so once the lid is removed, you'll see, again, another error entered
Actually,
into the HMI.
It powers it off on this one.
It powers it
It
off.
actually kills the main power. But like if we're doing the testing, what we'd actually, like I would fail. I would have just failed that test. Exactly. Yeah. So I mean that's a built-in safety of the machine, But you know, you guys are doing it.
Since we have the
You
hood
may have
off,
that on there.
you know, go ahead and take a look at the system as a whole, and you can see all the adjustment points. You know, you're going to be able to adjust the motor, and so you'll have to do that, adjust the tension on the belt here, and so you can't, as a learner, you just can't make your belt as tight as you can possibly get your belt, right? Because then you have to have a certain amount of play there, and so the students will measure that, and they'll understand that concept. They'll change the belt out to a chain drive, so they'll learn about that process. Again, lubrication. They're going to do alignments here on the pillars using shims, align the motor, and of course, you know, if you want to assess someone's skills, then you can make adjustments to the sensors. So if you don't have you can remove a sensor, you can adjust a sensor, and so again, the 50 skills that are delivered can be found in this book here that we have printed, and you can go through this. So this is, you know, great for industry, new employees coming in as frontline workers. That's what this is designed for. Some of the other equipment that we'll go over shortly will be more advanced. So this is a beginning process, and then those students would go to work, and then they would come back to advance their skills to maybe become an industrial maintenance technician. Or another great feature here is that because these components with motors and pneumatics and sensors and doing alignment, these are all skills that are related to a variety of industry sectors. So you could be going into an engineering pathway. You could be having a hands-on process for engineers, which a lot of the engineer schools and professional engineers go to technical colleges to get their hands-on applications to make sure that those students, those engineers can prototype something like this system, or you can be just really wanting to go through a short program to go work. And this delivers an industry-based credential from the MSSC. So this is an industry-based credential option. Mark has the hand tools, which seems very basic, but there are a lot of learners who really don't know how to use tools in the proper way. So if you even select a screwdriver that is too large for the application, you can strip out that industrial component, and that will require you to shut your system down.
And it's also, they use all these tools. Like, all these tools are used when they're working.
So they learn to use the tools in the correct application and cover this big book here with all of the skill instructions. So they would learn everything here, and the students can put their hands on the tools and put their hands on the equipment. And this is used in a lot of different areas. So now we can, any questions about this system?
Induction sensor in that.
It's a great entry-level system. You can think middle school to industry. We have folks in middle schools using this. We have industry clients using this. So that's it's just a multi-skilled technician. We can move over to some of our other systems here in the lab. A question.
We have the skill balls for scanning boxes.
Mm-hmm.
Of course, the biggest system. My question is, does it come with these books? I haven't seen it.
Yeah.
And two, does it come with a toolkit? Because I haven't seen that either.
Yeah. So there's an optional toolkit with the SkillBoss Logistics, and we printed these skills off ourselves. So this was on a disc that's available, so you can print this off as well. We printed it off just to show you, really visually see how many skills are covered, and so that you would have it here, and you can go through and flip through skill here, adjust an inductive proximity sensor. That's a skill. And so you can easily jump back and forth here. And you can pull this out if you're teaching a concept. You're able to pull this book and assemble and align a flexible coupling and shaft. Mark successfully restarted the system and cleared the errors, put everything back together. And so some users want to take this down to just a base platform and rebuild everything, which is involved. Others like to just make minor adjustments to check understanding and the competency of the learner. So you can go from very basic to advanced. So we'll move around the room here. We've discussed our automation system for robotics previously in another session. And we've covered the FANUC CNC
Yeah, 'cause
system
they'll
here.
reject it.
And I'll
it's
walk
just if it's
around
oriented
the
wrong way.
room
No, that's
Yeah.
here
what we would be using.
to introduce a couple of the other
Exactly that, and
units.
then show me how you lock it out, clear the jam.
Yeah. Yeah, no, that's exactly, yeah.
Whenever he
yeah.
is
You can get
available,
creative
we,
with it.
we could use his
That's what
help.
you want to do. I've seen, especially like on the mechatronics line, I've seen him do different things where it's like, cool, even from startup. And it actually works really well.
Okay. So we'll take it from the units we have here, just looking around the room. We're going to start with this system. This is electric relay control. So we talked about the Skill Boss earlier, and one of the foundation topics that a learner would need to cover and be proficient in would be hand tools. We talked about basic electrical theory, pneumatics, mechanical systems, lubricating, doing alignment on the shaft there to make sure that there's not a lot of vibration. So from the electrical side, you would cover basic electrical theory, and then this will be the next step moving into automation from a PLC, programmable logic controller standpoint. That's the brains and the computer, industrial computer that runs the Skill Boss. It runs industrial applications. And so here is the electric relay control. This is, folks use this, they tell us that this is the light bulb moment for the students where they're, after they get finished learning how to use a meter and basic schematics, they come here and then put these in sequence. So they're talking about if I push a button, one button, then something could happen, a light could come on. Then I have to push one button and two buttons for something to happen, just like I did here. And so this had me push the first button and the second button to extend the cylinders out. That's called an AND requirement. And so then it had a timer, it reached the pneumatic cylinder, hit the limit switch, it held it for a certain period of time using a timer. An interlock probably was in play there, and so it then held it and then retracted it. And I'm not sure what the circuit is. Someone built this, and I don't know what it is, so we'll have to explore this. We also have fault insertion built into this system and some of our other units. So the student or learner goes through and understands normal operation, how to do and or logic. If I push this, nothing happens, and then I push the second button that runs through the process. We would then introduce faults. So they would know that if I push this button, and then I push that button, it'll extend and run like it just did, but then it doesn't ever go back. And so now I'm locked. So how do I determine what the problem is? I have to get my meter, right? And then I have to go through and determine where my issue is. Is it the limit switch didn't get send feedback to my system? Is my push button broken? Is it a wire that's maybe cut? So that will be the process. So let's see if we can push one button and then two. Let's see if that works. No, just two. So you have the light come on, and then it held one, and I think when it hit this limit switch, then this one extended, then it held it for a certain amount of time, and now it's cycling through. And so that's just running a cycle. Let's see if I know how to stop it. Yeah, push that button to stop. So that's the process. So what we learned here, we physically wire this unit. Now once we physically wire the unit and understand the concepts, putting all these schematics into intricate sequences, now we're going to take that knowledge and we'll move over to PLCs. And so we'll jump over to this area here, and I'll come back to the other units in a second. But now we're moving in from basic electrical to relay control. Okay, we learn basic schematics and connecting a series circuit, a parallel circuit, things you start to learn in elementary school, all the way through high school. Now we're looking at industrial automation. We talked about relay control. Okay, now I'll put this together and I push that button, then it waits, then it retracts. So we're going a little bit more detail. Now this is the PLC, a programmable logic controller. This is the industrial computer that runs all industrial equipment in food and beverage industry, medical manufacturing, oil and gas industry, pipeline, production, just anything, any industrial application will be run with a PLC. This is by Allen Bradley. They're the largest supplier of automation systems in the United States. And we've now introduced not only the PLC, but the HMI. And so the HMI is a touch screen, just like your touch screen computer would be. And so the students will learn to build a screen. So they'll learn. We saw the push buttons back on the relay control system over here. If you push one button and two, the light comes on and the motor turns. Okay, we can still do that here. Okay, but now we would be writing the code on the computer. We don't have all the wires running everywhere anymore like we did before. Now you have rungs of ladder logic that have the schematics built in, and the schematics are going to then sequence through. And you're going to write that program just like you would be writing a code to create a computer program, very similar to that. And so we've introduced that, and it becomes more complex. And so we have different points here where we can use our meter to measure the outputs, because again, we can insert faults into this system. Now it's become more complex. We have 3 different outputs here. One is temperature control. If you're freezing pizzas, frozen pizzas, and your temperature gets too hot and your pizzas start to defrost, then you have to go and fix that system. So you find out what that means. When I hit a limit, when the temperature gets to this limit, I need to kick my freezer back on and get that food back to freezing temperature. So if that doesn't happen, the temperature doesn't stop rising, then you have a problem. So you'd have to figure out what that issue is. Could be in the PLC program, it could be in the fan, it could be in the power supply, and the same thing with a motor control system. So this would be an industrial application for turning motors. Maybe it's a conveyor system, and your conveyor's not working. And then you have a stepper motor, and so maybe you're counting how many spots that product would move down the line to perform a specific function. And then we have individual outputs here, so you can actually take this system and create your own project and write your own code and connect it here from the output and really do whatever you'd like to do with it. So that's the progression from basic series parallel circuits to relay control. We're learning to connect everything manually, and now we're writing digital ladder logic code and then performing mechanical functions using the industrial computer, the PLC. So any questions about, that's essentially the electrical and electronics pathway. Industrial motor control would be an additional application in industry, which is here on the other side of the room. And any questions about the electronics side? Okay, Mark, can you cover the motor control unit? Yeah. Just talk about what the applications are with motor control. Okay. Here you go. I'll give you the microphone.
All right, so with the motor control, you've got it has panels, so what's nice is it's modular, so you can actually take everything off depending on how you're building it, and as the students go through, right now everything's grounded together. It just slides off if I push the right one, and this will actually come right out, so you can build it however you need to. For testing or even when they're going through the skills, so you have like the operator station, control relay, lights, manual motor starter, the transformer. You guys see, cables are kind of crazy, but they do have schematics that they go through. First, it comes with any of the Amatrol. You may have walked you through this already, but it starts you very simple. Like, okay, cool, push the button, make the motor turn on. How does that need to get wired up? And then they add in the different parts as they go through it. I think this one should be going. Yep, it's wired correctly on this one. All your different switches, motor connections, you have options to get different motors for it too, so you can change up the type of motor that you're actually putting on it, and that'll swap out as to how it's on there. It also has the digital fault insertion, Fault Pro. So if you guys have seen that ever, they plug in, curriculum will say, hey, insert fault number 4. And they push 4 and it breaks it somewhere. So, which is kind of nice. And then they've got to figure out, okay, what's wrong? My motor won't spin. Or, where it is. Like the PLC one that has it, has the one that was the bane of my existence because I fell for it. It's like, why won't this, push a button, light's supposed to come on. My light's not coming on. I'm checking all the programming, I'm checking everything. Simulate burnt out light bulb. So, like, okay, cool, because you're going to run into that where, LEDs now, it's not as big of a thing, but they can still go bad. So why is this not working? Make sure your light's working. The actual light itself. So that's what's really kind of nice with it. You have limit switches, so you can just go through as they're different simulation. A liquid level switch, pressure, so you can actually hook it up to the air. So if it's getting that air pressure, it can go into it. Jamie, you look like you're about to say something. So.
Have you cover the curriculum and the...
Oh, you haven't got to it. Okay.
We haven't talked much about.
Do you have the other? Yeah, there we go. That's what I was looking for. So when it comes to all of the systems, you get get a nice stack. Some are bigger, some are smaller. One, they all come with an installation guide. So like I know for you guys at Mars, you guys have seen these. And if you haven't seen it for, when you guys are teaching, always recommend go through the install guide at the beginning of your semester. When teachers come back, go through it. Just that way, if you find something that's broken, like a student broke something last year, you can tell us. Instead of, oh, it doesn't work. Okay, cool. It's going to be a week. Got to order you a part. It actually just goes through setup. It also has all your part numbers. So if there's something that you need to reorder, I need another one of this, you can get it real easy that way. And you have your instructor's guide, which is, what's important to the teachers. Your answers are in here. So if you don't know it, that's kind of what's really nice about Amatrol is we get it all the time. People who don't, either they've never taught before, someone said, I'm in accounting, I'll do motors. So it's happened. And it walks them through on how to do it. So you have the curriculum completely laid out for you. You guys are using the Logistics Boss for some of the curriculum. You guys are using that, and you guys know how all this stuff works. But it tells you how the multimedia works. So you have either e-learning or multimedia. And it goes through and tells you all your skills and objectives. So this is what we're doing here. This is what we're doing here. And it all builds upon itself. So what's the first one? It's like explain, we don't want to do that one. Let me find some. Describe the operation of a three-phase motor. So just, how does that work? We're going to tell you how that works. And then you get to a skill, and it's going to do that step-by-step thing. So on any of these other units, if it says, okay, this is what this sensor is, now we're actually going to have you use the sensor and see how it works and build upon it. It goes through each of the modules, has your data sheets, so you can print these out for students. You get a digital version of this on a CD. And then for the important stuff, where's the self-review answers? Quizzes are already in here for you too. So you don't have to write your own quizzes. You just print them out, they're already there, and then the answers are in the back. And part of it, it's designed is, it's students working in groups working on a lot of it, but then you actually have like the hands-on tests where you tell a student, let me find it. So you have the skills with your answers too as you go through, but I'm trying to get to the right page.
The great thing about this is it helps it be transferable too. So that's one of the things that differentiates Amatrol. So if somebody leaves, like you said, a new teacher comes in, or for an industry, like we talked about, somebody moves and goes to a different company, you still got these guys, a new person come in and pick up, and it shouldn't be a drop off.
Usually takes me longer to set the thing up than to teach you how to use it. That's realistically what it is. You get something basic where it actually just shows you a drawing of plug this wire here of the actual panel, to then you get into actual schematics. And okay, cool, do this. And then you guys test it. There we go. Here's the skill assessments. So this would kind of be like their final test for that chapter or whatever you're working on. So it's just connect and operate a basic electrical control circuit that uses a push button switch. So you just do that. Can they do it? And it gives them a grade. It's graded like 0 to 4. So you can actually go through, you guys can use your own thing, but Amatrol kind of did it for you. So totally your call as to how you're doing it. Some places do it pass or fail. I guess it depends on where you're at. Or, okay, nope, you got a C. Cool, you figured out how a power switch works. Great job. But yeah, so that's kind of, doing all the different principles. You have the Prony brake, again, with you lockout, tag out on it as well. So it's kind of, we were talking over there with just the importance of the safety thing. You notice people are shutting it off and starting unplugging things and they haven't put a lockout, tag out on it. You want to get on them for it. So, because you want to make sure that's shut off, and that's kind of the going over the safety. Every unit comes with a student reference guide too. They give you one free, and if you want more, you can buy more. It's kind of like a textbook, but it's purely reference. So it'll go through what the curriculum covered, and it just gives you kind of what was written on a lot of it. So it's not set up in chat. It's kind of set up in modules, but just, you know, how does the circuit breaker work? And it just describes it. So it's just reference going through there. And then you have the e-learning or the multimedia. I think with you guys, we installed it locally from ours. And I don't know if you guys are using e-learning. I'm not sure. I didn't do that side. So you have either the online, or you have sitting in the classroom where it's only dedicated to one teacher or one computer. Usually recommend the e-learning, because what we're seeing a lot more now is you'll have students for their homework, go home and read the chapter, and then when they actually come into the classroom, all right, this is lab time. Now it's actually hands-on time, and that gives them more time hands-on without you guys having to sit there and lecture. Some teachers will go, okay, this is tricky. Let me actually lecture on this, or hey, did you have questions from this? All right, let's do the skills. So, yep. Jamie, anything to add? All right.
You're going to work on it. Okay, where are we at here with the camera? We're just going to jump in here as Mark continues to work on this. But okay.
That's why.
So we've talked about the skill boss. We've talked about relay control. We've talked about robotics. We've talked about CNC. We've talked about motor control. And bringing all of this together is one of the systems related to mechatronics. Okay, mechatronics is mechanical, electronics, all brought together. This is a representation of a manufacturing floor. It could be semiconductor manufacturing, it could be food and beverage manufacturing, it could be a lot of different types of manufacturing. But essentially what we have are the same core concepts that we discussed before. We have electrical, electronics, and mechanical systems all working together. So Mark has started the process, and so what we're doing is moving this part just through the system. You could be doing a quality control check. You could be doing packaging, and again, it could be food and beverage. I mentioned pizzas. It could be Coca-Cola. It could be semiconductors that you're packaging and putting together. The core applications are the same. So what the learner will then work with here is again your PLC. We discussed the PLC. That's the industrial computer. And then we have our pneumatics. These are the yellow lines you see on the system. So in order to set our pressures properly, we have to learn how to read a gauge. We learned that on the skill boss earlier. So we set our pressures correctly, make sure our parts are being fed. Our robot is doing that for us, so we don't need to touch anything. We're acting as an operator, industrial maintenance technician at this point. So we're watching our process happen. We have station 1, okay? Then we have station 2, where it's doing this station is checking the type of material, and it's the height. Okay, Mark says the height. So we're checking the height of the part, and it will reject the height. I think that's what's happened here. It will reject the height if the part is not within spec. So as a learner, I would have previously set the limits on that sensor. So I'd be working with the sensor and setting the bottom limit and the high limit. And if the part falls within either side of that, it will reject it. So we're making sure that, you know, if we're making biscuits, that our biscuits aren't burnt, right? And if they're burnt, we're going to reject that burnt biscuit. And the same thing would be applied here. As it goes through there and checks the height, if it passes that, again, we're using that PLC idea where it's saying, if this happens, then we move on. So now we're moving on. We've checked the height, we're good. Now we're going to check the material type, and we can actually add more components. So we can add RFID, right, to scan it. So if it's going to Katy, Texas, or it's going to Utah or New York, then we would be able to track that using our cell phone, using our smart device software. We are networking the system, so we're tracking everything that's happening here using smart sensors. But ultimately, we're going to get through the process, and then we'll it will sort by make. And now we're added a level of complexity here with 3 different types of materials. So, so that's it. But there are several smart sensors here. Let's see if we can find a smart sensor. This is okay. So this is a smart sensor for the pneumatics, and it's checking. Before we saw the pneumatics was on or the pneumatics was off. Now we can detect if there's a leak. So if we detect that there's a leak we're using a smart sensor, then we can do predictive maintenance, or we could plan to do some maintenance when we're not running the system or we're shut down. So there are a lot of different sensors that can be added to the unit. And so mechatronics, robotics, electrical, there's a problem, we're going to have to use our meter to check that. We were able to check our mechanical systems with our motors and our pneumatics and carry on what we've learned to this system, which is a smart factory. Of course, we've learned to program the robot already as well. So all of these things are going to be brought together in one system, fairly complex. So there's a lot you have to learn. We mentioned learning our tools and using our tools properly. So we definitely need to make sure we're doing that right before we kick this thing off and make it function for us. So, any questions about the mechatronics or smart factory system? So, thanks, Mark, for getting that going. We're going to move down a little ways. I'm just going to take these one at a time here. So here we have process technology. So if we're working again in the oil and gas sector, if we're working in food and beverage sector, we're always going to be working with tanks or pipes, and we're going to be pushing some fluid through. And here, this one focuses in on level control and flow control. So we're going to actually have the fluid. We don't have fluid in here, but right now, but the fluid will be moving through this in case of water, and the students will be asked to keep a certain level. So there's another control panel that will go along with this, the electrical component, and they're going to connect that circuit and make sure that we're controlling level appropriately here. And so this is an automated system. We could have manual gauges, but here we have electronic controlled gauges, and so this is our portable process technology, and this has introducing some smart sensors onto it. The same as this one. This is from SESME, Clean Energy Smart Manufacturing Institute. This was a project that Amatrol had worked on with the SESME, and so SESME is focused on making sure that that industry is optimizing their production and the energy consumption. So you think about how motors run. Well, that plant has to get energy from somewhere, and it's expensive to produce that. And if you're wasting it, it costs the company a lot of money, and it is not very efficient for anyone, and it's very costly. So here there are a variety of sensors that are built onto the unit, and these sensors can actually be applied in industry or in a lab. So if you have some motor that you're working with in your plant, then you can, or at your school, you're able to take these sensors, connect those to your actual production line, and get data back from that. Maybe test it out, to try it, and of course to learn about that sensor if you're thinking about introducing or implementing a new technology at your facility. You could use one of the sensors that's built into this unit. And so we could just see we have a vibration sensor, we have a part counter sensor. So if you're working with different types of parts, we saw before acrylic versus metal parts, and just a couple other pieces here. A temperature sensor and the fan, we saw that previously on the PLC. So now we're able to monitor the function of those components using the SESME device, really focused on energy consumption and operating efficiently. So that's getting into your predictive, preventative maintenance and really optimization. Very sophisticated but important to industry. Here's our large mechatronic system. So this is a floor standing unit that is even more advanced. So we continue to advance the learning for the students. Again, they can go from middle school with a skill boss, basic electrical theory, all the way through high school. Industry can use this. There are semiconductor manufacturers using this process, or very similar processes. Of course, automotive manufacturing, a lot of different industry sectors. But we have the PLCs again. very common. We've discussed that several times. This unit allows you to take these PLCs out and put them on the table and teach the basics of PLCs. So it's a multi-function system. There are several carts. The one on the end is networking. So we're not only running the system, but we're tracking everything that's happening, and we're following that production process all the way through, allowing us to optimize that. So you're able to make adjustments to the system, find out why it's not functioning properly. Is the motor causing you a problem? Is it the pneumatic line leaking, et cetera? But again, safety's built in. We have the push buttons. We saw that, very basic push buttons. If I push the button, the thing starts. If I push another button, it will stop. That's basic PLC programming using their meters. But what we're going to do is assembly process. So we're actually assembling something now where, as before we were just pushing one part through, now we're actually assembling a part much more complex. And so the students have to understand torque, and have to understand, they'll test the pneumatic valve that's put together. They'll test it to make sure it's assembled properly. So we're doing a quality control check on it. And then we have a lot of just more sensors. So you can obviously see this is more complex. We built a lot of different smart sensors into the system. And yeah, of course, an HMI, we saw that previously. We'll build an HMI out. This system has been around for a while, and a great thing with this is that it's improved and grown over time. So if you make an investment in a system like this, it doesn't become obsolete. You can add smart sensors to it. You can add networking to the unit. You could add 8-10 different carts. We have an autonomous ground vehicle that will move around and work with half dozen robots, so it can expand into what we call enterprise systems, much bigger and more complex. But we see this a lot in universities, colleges with advanced programs in automation. We'd have the robot on the back like we saw before, 2 robots on the end, palletizing it. So again, assembling a part, testing the part, then packaging the part, and then moving the part back to be sent out on the truck, if you will. So the complete manufacturing process is what's represented here with the Amatrol Smart Factory system, even enterprise system. So that's an overview of some of the things we have here. Any questions about Amatrol's content? Again, as Mark had reviewed, we have the curriculum. So every objective that's covered, Amatrol delivers that through either a book or online using multimedia. Each skill that's covered that we discuss has step-by-step instructions that the students or the instructor would follow, so you don't have to make up any of the skills. Everything's there for the students, which is important because that allows the students to not only not only see the skill or see the content, but actually do it. And that's the difficult part, is to get the students to put their hands on the equipment and physically perform the skill, learn it, and then go to work. And so at the end of this, all of the learning, the instructor has an opportunity to then go back and assess the skill and authenticate what the student has learned. And they'll prove that before they leave either the school or before they go back to work on the floor, the plant floor. They'll prove that they have the skill. So they'll learn it with a book, learn it through e-learning, follow the skill instructions. The instructors will assess them. We'll all prove everything out, and then get a certification and go to work. So that's the goal here, is to upskill students and get great jobs. So that's an overview of Amatrol. Any questions you have regarding that? We have some books. So look, grab some of the books that have PLCs if you want to review some of the content. We have mechanical drives. Here's production assembly. Here's process control. If you want to learn what's covered in pneumatics, just pick up a book and then turn to the page 3, and this will tell you exactly what's covered in this concept. So, it's really an objective process. You'll know what you're getting with each of the systems by looking at the objectives. So, thank y'all for attending. Whoever's online, hello. Thank y'all for attending. Y'all have a good day. Have a good weekend. Yes, sir. One.